we are going to look at a limiting reagent problem with a mole-to-mole stoichiometry calculation. How many moles of water can be produced from 2.5 moles H2 and 4.5 moles of O2? So we start off with our balanced equation and we look at what the question is actually asking us to find. And that will be our X. So it says how many moles of water can be produced. So above our water, I'm going to write X moles. Now it's giving us two different amounts of reactant. So we're going to have to do a stoichiometry problem with each of the different reactants. So to solve, we are going to do two separate problems in order to find our answer. So I'm going to start with the first given value, our 2.5 moles of H2. So above my H2, I'm going to write 2.5 moles. Now, when solving a mole-to-mole stoichiometry problem using proportions, we use the coefficients from the balanced equation as our bottom numbers in our proportions. So my bottom number under H2 is going to be 2 moles, and my bottom number under H2O is going to be 2 moles. So now I have my proportion, so I'm going to rewrite it to solve. So I have 2.5 moles over 2 moles, and that equals X moles over 2 moles. Now at this point, I want to cross multiply this way, so I get 2 times X, and that equals, multiplying the other way, 2 times 2.5, which equals 5. That's not a 5. We're going to erase that. That's a 2. We are going to write a 5. There we go. So now, to solve for X, we divide both sides by 2. And 5 divided by 2 comes out to be X equaling 2.5 moles. So when the 2.5 moles of H2 reacts, we get 2.5 moles of water produced. All right, now we're going to work a stoichiometry problem using our other given value, which is our 4.5 moles of O2. Now, our bottom number under O2, since there is no number that's listed there, it is understood to be A1, so we have 1 mole on the bottom for our second proportion. So, second proportion, we get 4.5 moles over 1 mole, and that equals X moles over 2 moles. So, once again, we cross multiply, and when we multiply this way, we get X times 1, which is just X, and that equals, we multiply the other way, this way, and we get 4.5 times 2. And 4.5 times 2 equals 9.0 moles. And both of these are moles of H2O, so I will write H2O. Now, given these two amounts that we just calculated, 2.5 moles of H2O and 9 moles of H2O, that came from our two amounts of reactants, we look for the amount of product that is smaller. And in this case, our smaller product produced is this one, our 2.5 moles of H2O, this one right here. So in picking the smaller product, the reason we do that is because that is the product that has been limited by the reactant that created that amount of product. So remember, when you get your two values of product produced from using your stoichiometry calculations for both of your given values, you pick the one that's smaller, and that's going to be the answer to our question. So that answers the question, how many moles of water can be produced? It's 2.5 moles of H2O. Now, our secondary questions are, what is the limiting reagent? And what is the excess reagent? So the limiting reagent is the one that limited our amount of product that was produced, or produced the smaller amount. What produced our smaller amount of product is our H2. So our limiting reactant in this case is our H2. And limiting reactant and limiting reagent are the same thing, even though the two words are different, reagent and reactant, they mean the same thing. So if H2 is our limiting reactant, then that makes the other reactant involved our excess reactant. So in this case, the O2 would be our excess. So when this reaction has gone to completion, we will end up with 2.5 moles of H2O and some excess O2 left over that was not consumed in the reaction. And that is our level 1 or mole-to-mole limiting reagent problem.